Here's another example of graphing polynomials, and let's take a look at this. Now, again, it's in factored form, so we always have some zeros. This is kind of like the last example. Sorry about that. There's some similarities, but I just noticed that. So let's go on with it. So we've got 2x plus 1 cubed, x minus 1 cubed, x minus 3. So the zeros or whatever make the value of the function equal to 0. Remember, those are the zeros or the x-intercepts or the roots, all the same numbers. Okay, so if I put -1 here, I get 0 as a factor of 0. If I put 1 in here, I get a factor of 0. If I put 3 in here, I get a factor of 0. So these are the values that make the value of the function or the vertical position 0. Okay, -1, 1, and 3. So I put those on my graph, -1, 1, and 3. Now the y-intercept is when we put 0 in for x, f of 0. Because when x is 0, it's going to be on the y-axis. So if we do that, we have 0 plus 1 is 1, so 1 cubed, -1 cubed, and 0 minus 3 is -3. 1 cubed is 1, -1 cubed is -1, so we've got 2 times -1 times -3, that's going to be positive 6. So there's my intercept, so I mark that in. Now we look at our end behavior, and our end behavior model. All I have to do is just add up the exponents, 1, 2, 3, 4, 5, 6, 7, so it'd be x to the 7th. In other words, if I multiply these all out, the highest degree term would be x cubed, and x, if we multiplied all those high degree terms, we'd have x to the 7th. Well, that's positive odd, so this is going to behave like just x, y equals x. So my behavior is going to be lower left going down to negative infinity and going up to infinity. So there's my behavior. Now, remember, it's going to start down here. If the power is odd, it's going to cross. If it's even, it's going to bounce, and these are all odd, so it's going to go like this, and like this, so it's going to cross. Now the y-intercept is right between two of the zeros, or two of the x-intercepts, or two of the roots, same thing. So I figure it's going to be symmetrical, so I'll make it almost parabolic. So it's going to maybe come down a little bit steeper like this. That's going to come down. Now, what's the low point going to be? Well, I've got a 1 and 3, so the low point is going to probably happen at 2. But I don't know what that is, so let me just, you don't have to do this, but I can just take f of 2 and see what it is. So if I put 2 in here, I've got 2 times 2 plus 1 is 3. And 2 times 2 minus, and then this is going to be 2 minus 1, which is 1. And 2 minus 3 is -1. And 2 plus 1 is 3. 3 cubed is 27. This is going to be 1 cubed, which is 1. This is going to be -1. And if we multiply that, we get a 1 negative sign, and 2 times 27 is 54. So it's going to be very low. It's going to be way down here. So I'll put this up just as an estimate, but it's going to be even lower than that. So it's going to come down like this, a very low point, and come back up, and look something like this. And there's your something that matches your end behavior. You might want to have it flare out a little bit more so it looks like it's not vertical. And you don't have to do this. I mean, if you put your point like this, that would be fine anywhere, because we're not requiring you to do that. But it's something we'll probably do a little bit later, just so you have an idea of what you can do. And that wasn't too hard to find the value of that function. Put it in there, especially when it's in factored form. So that's what that looks like. So that's not too bad. Gives you a pretty good graph and pretty good idea. But like I said, this point would be much lower, but I don't even have room on my paper here for that. So that's just an estimate. That point is actually 2, -54, so that goes way down there. Okay? So if that makes sense.